Okay, so picture this for a second. You take an AI system, right?
Uh,
And you feed it some articles, maybe a dense technical report, could even be just a couple of web links.
okay.
And almost instantly, it spits out. Not a summary, no. It gives you a full-on multi-speaker podcast.
Wow. Okay.
And I mean lively,
Ah.
with all the natural pauses, the ums, the kind of easy back and forth you hear on shows like this one.
Right.
What if that's actually here?
I know. That would be something.
Well, today we're doing a deep dive into exactly that. It's called MoonCast. It's this really groundbreaking AI system from a big collaboration, University of Science and Technology of China, Moonshot AI, the Chinese University of Hong Kong, and Microsoft Research. Quite the team.
Yeah, that's a serious lineup.
And our mission today, basically, figure out how MoonCast pulls off this high-quality, zero-shot podcast generation. What challenges did they have to overcome? Because there were challenges.
Oh, absolutely.
And maybe most importantly, what does this all mean for, how we make and listen to audio stuff in the future? We're going to get into all the juicy details from their research paper.
Sounds fascinating. Let's get into it.
So when most people think about AI speech, they probably picture, I don't know, a slightly robotic voice reading text, right? Very monotone.
Yeah, that's the common image, like a screen reader maybe.
Exactly. But a podcast, a real conversation,
Yeah.
it's just so much more complicated than that, isn't it?
It absolutely is. And you've hit on the core problems that have really stumped AI in this area for a long time. Previous text-to-speech, TTS systems, they've gotten really good, actually.
Yeah, some sound quite human now.
For short things, yeah. Single sentences, individual words, they can nail that.
Mm-hmm.
But real podcasts, like you said, they throw up two massive hurdles, huge ones.
Okay, what are they?
Well, first is just the sheer length. Podcasts aren't just a few lines. They go on 4 minutes, often many minutes. And usually with more than one person talking. So this is way beyond what most systems were built for. You need smooth handoffs between speakers. And you need to keep things like the rhythm and intonation, the prosody sounding natural over that whole time. Plus the actual voice quality, the timbre, needs to stay consistent. It can't drift.
Okay, so length and consistency. What's the second hurdle?
The second one is maybe even trickier. Spontaneity.
The human element.
Exactly. Podcasts, good ones anyway, feel spontaneous. They sound like real talking. Think about how we actually talk. It's full of, human stuff.
Like filler words.
Yeah, filler words like hesitations when you're thinking. Sometimes you make little mistakes, repeat yourself slightly.
Sure.
And those little feedback things like saying yeah or right when someone else is talking. Back channels.
Mm-hmm. Shows you're listening.
Exactly. Capturing all of that natural conversational style, it's incredibly hard for AI, which usually learns from clean, formal, written text.
It really does make you appreciate how messy, in a good way, human conversation is.
It is.
When I'm trying to explain something complex, I'm definitely throwing in ums and ums just to buy a millisecond to think. It's not polished.
Right. It's part of the process.
So trying to get an AI to replicate that feeling, that natural back and forth you hear on a deep dive like this, that sounds like a massive job. It's not just the words, it's the whole vibe.
It's a huge undertaking. Yeah, the vibe, the flow.
So faced with these really tough problems, the length, the spontaneity, how did the MoonCast team even start to tackle them? I'm guessing it wasn't just one simple tweak.
No, definitely not. Their approach is really clever, actually. It's a 2-stage pipeline.
Okay.
And the key insight they had, something they actually showed empirically in the research, is that getting that spontaneous sound isn't just about the fancy audio model at the end.
Oh.
The script itself is just as crucial, maybe even more so in some ways.
Huh. So the text matters as much as the voice.
Precisely. So their solution has 2 main parts. Stage 1, they call it the spontaneous script generation module.
Right.
This uses a large language model, an LLM, to take the input. It could be articles, reports, even just a URL.
So raw text.
Yeah. Raw, often formal text,
Yep.
yeah. And it turns that into a conversational, spontaneous-sounding podcast script, like transforming an essay into a dialogue.
Okay, interesting. Then what?
Then that script goes to stage 2, the spontaneous podcast speech generation. They also call it the audio modeling module.
Got it.
This stage takes that carefully written script and actually creates the audio. High-quality, natural-sounding podcast speech. And here's a key bit. It can do this using voices it hasn't been specifically trained on.
That's the zero-shot part.
That's the zero-shot part. It can adapt to new voices on the fly.
Okay, let's zoom in on stage 1 then, because that sounds like where a lot of the magic happens. How do you get an LLM, which is usually good at, formal writing, to produce something that feels genuinely spontaneous? Seems tricky.
It is tricky, and you're right, it's not straightforward. They found if you just ask the LLM, hey, turn this article into a podcast script, you often get something kind of vague.
Yeah, probably still sounds too formal.
Exactly. Too formal, loses important details, and definitely lacks that spontaneous feel. So MoonCast does something clever first.
An intermediate step.
Kind of, yeah. First, it generates what they call a briefing document.
Okay, what's that?
Think of it like a structured summary or outline. It pulls out the key points from the original text title, abstract main topics, citations, conclusion. But crucially, it also adds paragraphs to explain any tricky technical terms or concepts.
Ah, so it pre-digests the info for a general audience.
Precisely. It makes sure the core content is clear and accessible before trying to make it conversational. It gives the LLM a really solid base.
Makes sense.
Then, using that briefing document, the LLM generates the actual podcast script. But it's not just told, write a script. It gets very specific instructions.
Like what kind of instruction?
Really detailed stuff, like structure. Create an engaging opening and closing. Set the right tone.
Nope.
Format. Output it in JSON with two specific speakers. Speaker 1 is the host, kind of controlling the flow. Speaker 2 is the guest, bringing in the main content.
Right, defining the roles.
Exactly. Content. Make sure the logic flows, cover all the info, use rich mood words, explain jargon simply, keep the information density manageable, don't overwhelm the listener.
Wow, that's quite specific.
But here's the clincher for spontaneity. The LLM is explicitly told to add those details from real human chat.
You mean the ums and us?
Yes. Filler words like, so. Response words like, yeah, right, okay, right. Even little repetitions, informal grammar. They even use formatting like extra spaces or commas to signal natural pauses. It's like they're teaching the AI the rhythm of conversation, not just the words.
That's fascinating. So it's not just generating text, it's generating text that looks like a transcript of spoken language.
Exactly. They basically figured out through trial and error that you have to bake that spontaneity into the script itself. If the script is too clean, the final audio won't sound right no matter how good the voice synth is.
Right. The source material dictates the output quality.
Absolutely. It bridges that gap between the formal input text and the conversational audio they want at the end.
Okay, so they've got this script perfectly formatted, full of likes and you-knows. How do they turn that text into actual sound that feels like a real podcast? Minutes long, two different people talking, flowing naturally. That still sounds like a massive technical jump.
It is, and this is where their audio modeling comes in, specifically this long context language model-based audio modeling. It's pretty innovative stuff.
Okay, break that down for me.
So instead of handling each speaker separately or breaking the audio into tiny chunks like older systems might,
Which can sound disjointed.
exactly, can sound choppy. MoonCast uses a single unified model to process the entire sequence of what they call speech codes. Think of speech codes as a detailed digital representation of the sound, not just the words, but the pitch, the timing, the tone, everything.
The whole conversation at once?
The whole thing. All the speech from speaker 1, all the speech from speaker 2, even the little pauses and transitions between them, all processed together.
Why is that important?
Because it allows for much better contextual coherence. The model understands the flow of the conversation across speakers and over time. It helps maintain consistent voice quality and natural intonation for the whole duration.
And these sequences are long.
Oh, yeah.
Right.
They mention a 5-minute podcast can be like 15,000 of these speech codes long. That's a huge amount of data for one model to handle coherently. It's a semantic model, meaning it understands the context.
Wow. Okay. How else do they manage that complexity?
They use some smart design choices. For one, they interleave the text script and the audio codes so the model sees both together. And they use a special marker, a speaker change token, every time the turn shifts.
Like a little flag saying, okay, other person's turn.
Exactly. It makes the system more robust, helps it keep track of who's supposed to be talking, reduces errors like assigning speech to the wrong speaker.
Makes sense.
And then there's how they train it using curriculum learning.
Meaning they teach it step by step.
Sort of, yeah.
Yeah.
It learns in 3 stages. First, just basic single speaker stuff to get that zero-shot TTS ability down, making one voice sound good.
Okay.
Second, they train it on 2 speakers, longer context, but using things like audiobooks. So multiple voices, long duration, but not necessarily spontaneous chat. builds up its ability to handle length and consistency.
Right, less complex interaction.
Exactly. And then finally, the third stage, they fine-tune it on actual podcast data, real conversations.
Yeah.
That's where it learns to master all those spontaneous elements, the fillers, the hesitations, the back channels.
So it builds up the skills progressively.
Right. And one more really clever bit is how they actually generate the final audio waveform from those speech codes. It's called the chunk-wise autoregressive speech detokenizer.
That's a mouthful.
It is. But the idea is smart. Generating super long audio all at once is computationally very expensive, takes tons of memory.
Right.
But if you just chop it into, say, 30-second chunks and generate them separately, you get audible seams. It sounds stitched together.
Yeah, those awkward cuts.
So MoonCast does it differently. It generates small chunks, maybe only 3 seconds long. But here's the key. Each new chunk is generated based on the history of the chunks generated right before it.
So each piece knows what came just before.
Exactly. It allows the audio to flow smoothly across those chunk boundaries. No jarring cuts. It maintains consistency and fluency over the entire length. It's a really neat way to get around that segmentation problem.
That really does make you appreciate just how much goes into making something sound naturally continuous.
Oh, absolutely.
We take it for granted in human speech, but replicating that seamless flow, avoiding those robotic cuts,
Yeah.
it's clearly a huge engineering challenge.
A massive one. Getting that naturalness is hard.
So after all this complex engineering, the 2 stages, the fancy models, how good is it? Did MoonCast actually deliver on that promise of natural, coherent, spontaneous podcast audio?
Well, based on their experiments, yeah, it performs really well, significantly better than previous systems they compared it against.
In what way?
They did subjective tests, had people listen and rate the output. And MoonCast consistently scored higher on things like coherence, how well the conversation flowed logically, and especially on spontaneity.
So it sounded more natural.
It sounded more natural, yeah. For both Chinese and English podcast generation, which is also notable, it validates their whole approach, especially the long context audio modeling.
Okay.
But here's a really cool part of their testing. They specifically isolated the impact of that spontaneous script we talked about earlier.
How they do that?
They generated audio using 3 different script types. 1, ground truth scripts. These were basically transcripts taken directly from real podcasts, warts and all.
Okay, the real deal.
2, written scripts. They took those ground truth scripts and used an LLM to remove all the spontaneous bits, the terrace repetitions, making them sound like clean written text.
Right, formalizing them.
And 3rd, spontaneous scripts. They took those cleaned up written scripts and had the LLM reinsert spontaneous elements, mimicking their stage 1 process.
So comparing real, cleaned, and AI spontanized scripts, what do they find?
The results were super clear. The ground truth script, the real one, got the highest spontaneity score. No surprise there.
Makes sense.
But when they used the written script, the one with spontaneity removed, the score dropped a lot, by almost a full point, 0.95 points on their scale.
Wow, that's a big hit just from cleaning up the text.
It is. But here's the kicker. When they used the spontaneous script, the one where the LLM added back the ums and us, the score jumped almost all the way back up. It was only 0.13 points lower than the original real script.
Get out. So the AI putting the ums back in made it sound almost as natural as the real thing.
Pretty much. It's a massive aha moment, right?
Totally.
It proves that for AI audio to sound genuinely human and engaging, it's not just about the voice engine. The script itself, with all those supposedly messy conversational bits, is absolutely vital. Those aren't flaws, they're features.
That's incredible. It really changes how you think about generating this kind of content. The imperfections are actually perfect for realism.
Exactly. We humans are complex communicators.
Okay, so MoonCast is clearly impressive, a big step forward.
Yeah.
But no technology is perfect, especially cutting-edge stuff. Are there still quirks, challenges, things they're working on?
Oh, for sure. And the researchers are quite open about them, which is good. One issue they mention is hallucination.
In what sense? The AI making things up?
Not quite making up facts, but more like confusing speaker identities. Sometimes it might attribute a line of dialogue to the wrong speaker.
Oh, okay. Why does that happen?
It can happen when the text itself is a bit ambiguous. They give an example like, today we're discussing climate change and its impact.
Right.
Is that one person saying as a filler, Or is it speaker one saying climate change, speaker two interjecting, and speaker one continuing? The model can sometimes struggle to figure that out correctly.
I see. Yeah, context can be tricky.
Another related point is a trade-off between spontaneity and hallucination. If they tune the model to be more creative, to generate more of those spontaneous elements,
It might also make more mistakes.
it seems it can sometimes lead to more of these speaker confusion errors. So finding that sweet spot is a balancing act.
Okay, what else?
Data quality is another area. The process they use to get training data involves automatic speech recognition, ASR, and also speaker diarization, figuring out who spoke when in the original audio. These tools aren't perfect.
So errors can creep into the training data.
Exactly. And they also mentioned that their current pipeline tends to filter out moments where speakers talk over each other.
But people do that all the time in real conversations.
Right. So filtering it out while maybe simplifying training actually makes the final output a bit less realistic in that specific way.
Interesting nuance.
And finally, they definitely address the ethical considerations.
Yeah, I was wondering about that. Making voices sound this real.
It's powerful. And because it's zero shot, it can potentially mimic voices it hasn't been trained on extensively. So there's a risk of misuse, creating deepfakes, voice phishing, that sort of thing.
Right.
The researchers acknowledge this directly. They stress the need for good synthetic speech detection tools and ways to flag malicious use. It's that classic double-edged sword of powerful tech.
Absolutely. It really brings home that question. As AI gets scarily good at sounding human, how do we maintain trust? How do we know what's real? It's a big societal question brewing.
A huge one. And it's only going to get more pertinent.
So let's kind of wrap this up. MoonCast seems like a genuinely significant leap, generating long, multi-speaker, really spontaneous-sounding audio just from text. That's pretty remarkable.
It really pushes the boundaries, no question. It shows so clearly that you need both things. That intelligently crafted, spontaneous script and the sophisticated long context audio modeling. It's the combination that unlocks that naturalness.
The art and the science working together.
You could say that, yeah. The art of conversation meeting the science of AI.
So here's the final thought to leave everyone with. If AI like MoonCast can now reliably create these natural multi-speaker conversations from almost any text source, what happens next?
Right.
What kind of new, personalized, on-demand audio could we see? Imagine AI hosts discussing literally any topic you choose, tailored just for you.
Instant custom podcasts.
Exactly. How could that fundamentally change how we get information, how we learn, maybe even how we relate to content? It's definitely something to think about as this technology continues to evolve.
Absolutely. A whole new world of audio possibilities might be opening up.